The concepts of curvature, equal curvature, and continuous curvature are very important in complex, swoopy shapes. Curvature is identified as the inverse of radius, so that curvature C is equal to 1 over r. This is shown graphically when a curvature comb is shown on a spline or other curved sketch entity. The curvature comb can be shown by right-clicking on the spline and selecting Curvature Comb from the menu. As the curvature comb gets taller, it means that the radius of the curve is getting smaller, making a tighter bend. When the curvature comb dwindles down to nothing, as at the left end of the spline, it just means that the spline is flattening out into a straight line. If the curvature comb on a spline flips from one side to the other, the point where it crosses is called an inflection point, because the convexity flips. A curvature comb on a circle is a comb of constant height all the way around. Equal curvature is a situation where two arcs of the same radius touch at their ends. Note that tangency does not concern curvature at all. Here is a situation where the arcs are tangent but have different curvatures, so the curvature combs between them are different heights. Continuous curvature is when the curvature combs of two splines transition smoothly over the intersection between them. This makes for a smooth transition, as shown here. The equal curvature sketch relation causes the foreshortened radius symbol to be shown along with the spline handle. Notice also the smooth transition between the combs of the two splines. When splines are made into surfaces, the transition between surfaces are very critical. Transitions that aren't tangent at all are seen as a hard edge. Think of a car body with a sharp crease and how the crease interrupts reflections. A transition that is simply tangent is less abrupt than a hard crease, but the point where the curvature changes from one value to another is definitely identifiable. Transitions where the curvature changes smoothly across the edge are indistinguishable and are made by matching the curvature on either side of the transition. Curvature combs on all curved entities can be applied from the right mouse button menu. For splines, they can also be applied from the Property Manager. Zebra stripes are another tool useful for identifying curvature changes. Here, zebra stripes are used to visualize curvature changes in three scenarios: a spline transition on the left, an arc fillet transition in the middle, and a sharp crease on the right. Zebra stripes work by making the part fully reflective and puts the part in the room with black and white stripes painted on it. The room can be either rectangular or spherical. Often in swoopy modeling, we avoid transitions by making smooth faces as single features when possible. The entire outer face of the pasta scoop model will be created using a single feature, guaranteeing a smooth outer face. The inside of the scoop and top face of the handle will be made from different features and will need to match the transition as closely as possible.